In this video, within just a few minutes, you're going to learn how to design a custom printed circuit board using an ESP32 module. So this is the schematic that we're going to be designing the board around, and we're using the ESP32S3, which is a newer version of the ESP32. We're using the ESP32S3 mini module with the PCB antenna built into the module. And then we have over here, we just have a micro USB port. We have our power and our two data lines coming in, and then we have ESD protection for those pins. And then down here, we just have our linear regulator, which takes the 5-volt USB and steps it down to 3.3 volts. Now, in this shortened version of this tutorial, specifically for YouTube, we're going to keep things a little bit extra simple. For example, I'm not going to connect to any of the I/O header pins. Also, this design has no peripheral functions. But however, in the link in the description below, you'll be able to access the full unedited version of this tutorial where we actually design a slightly more complicated board. All of these I/O pins, will actually connect those up to header pins so you can actually use the board along with the breadboard. Then we'll also add a temperature humidity sensor and an RGB LED that you can control. And then also, instead of just an older USB micro connector, we'll use a USB-C connector. And if you happen to be a member of my Hardware Academy, I've got this full tutorial for the more complicated version of this board set up as a course with easily digestible lessons. You can easily access all of the design files. And of course, you have access to me and other experts to ask any questions that you have. And then also, we're going to order the boards and get those back and program and test them. And as a member, you'll be able to get one of these boards shipped to you. Okay, so let's take a quick look at each of these subcircuits. Here we have, this is the main ESP32 module. We have a whole lot of I/O pins that we're not connecting up for this project, but you could bring those out to header pins or connect them to other peripherals. This is also where you'll access other serial interfaces like I2C and SPI. And then, so none of those are connected. We have our 3.3 volt supply. This is output from our linear regulator that powers the ESP32. Then we just have our two decoupling capacitors for that. Then we have, the module has a whole bunch of ground pins. This symbol just has them all on top of each other. So you just need one ground connection. It just makes it a little bit neater, but you can see there's a bunch of pin numbers here. You may see some symbols where they actually have each ground pin listed separately. I just like this one because it's a little bit easier to hook up and a little bit cleaner schematic. Then we have, the only thing left we have is our enable. So this has got a pull-up resistor, a capacitor, and a push button. So what happens when power up, this capacitor C3 acts like a short because it's not charged up yet. So the enable pin is pulled low, and then it's pulled high by being charged up through this 10 kiloohm resistor that charges the C3 and pulls up the enable pin eventually to the 3.3 volt supply. So what this does is it just gives you a power on reset. As soon as you power it on, the enable's low and then it goes high, and that does a reset. You can also force a reset at any point by just pressing this reset button, which grounds the enable pin. And then when you release it, it goes back high, re-enabling it. So that's a reset function. Then the other thing we have down here, which is nearly identical, except there's no pull-up resistor. We just have this capacitor and a push button with just boot that goes to ground. And what this is used for is for putting it in programming mode. Then the only other pins we have here are the two UART pins, which we're not using. This is just a transmit and receive. Okay, so that is an overview of the schematic for the ESP32 module. Keep in mind, since we're using the module, some of the other circuitry is already embedded inside the module. So it's pretty simple when you use the module. Then over here, we just have our micro USB. We have our shield and our ground. We have our USB power supply, the 5-volt supply. Then we have our two USB, the positive and negative. This is a differential pair. So we'll get into how you go about routing these because they need to have some level of impedance matching. And then down here, we have our ESD protection diodes. This is a chip that has 4 protection diodes. We're using 3. one for each data line and one for our 5-volt supply. Then down here, the only thing left is our simple linear regulator, which takes 5 volts in. We have an input capacitor, and then we have 3.3 volts out with our output capacitor. For any regulator, you need to have an input and an output capacitor to both stabilize the feedback loop that happens inside the regulator, but also to help with any transients. Then we just have the enable pin pulled high to VN, so it's always enabled whenever 5-volt USB is present. We output 3.3. We're using an adjustable version of this linear regulator, so that means we just have the resistor divider. The feedback divider is external. So for fixed linear regulators, fixed voltage outputs, this resistor divider is just internal to the chip, but on an adjustable, which generally ends in an 01 part number, then you can just bring the resistors external so you can set the output to whatever you want. In this case, I've set it these resistor dividers to give us 3.3 volts on the output, and you can refer to the data sheet or for the simple formula for calculating these resistors. And then the only thing left is we have our power on LED that illuminates whenever we have power, and we just have a 5.1 k ohm resistor to limit the current through that LED. Okay, that is everything in the schematic. Now we're going to convert this over into the PCB layout and begin connecting everything up. Okay, the next step is we're going to go under Tools and we're going to do Update PCB from the schematic. And what that will do is place all of the components. And we'll do Update and Close, and we can drag it right here. Okay, you can see all of our components here. I'm going to just start quickly. I'm going to let me pull out those passives. So we have here's our main module. We'll have our USB connector here at the other end of the board. We'll have our ESD will be down here by the USB connector. Let me just get rid of these part numbers, okay? And then we just have our LDO, our low linear regulator, and our power on LED, which we'll just move over here near it. And then we have let me actually move this back down. Let's put our 2 switches here. Okay, there are the primary components. Then we just have our R's and C's. So what I'm going to do now is I'm going to draw our board edge. So I'm going to go and I'm going to select edge cuts, and then I'm going to do a rectangle, and we want this here. So this is the PCB antenna on the ESP32 module, and we just have to make sure that this hangs out over the board. You don't ever want any ground above or below this antenna. So the safest way is to have this just hanging out over the board. So I'm gonna just start my board edge here, and let's go down here, and you can see the PCB edge there for the USB port connector. There we go. Center this up a little bit more. Let me zoom in here. Okay, so there we have the module placed. We have our USB connector. Okay, it's just a matter of we start connecting things now. We can bring in all the passives in a moment, but the first thing I want to do is connect up the USB data lines. Now, the ESP32 S3 only supports up to full speed USB. So it's not going to be the high speed USB that you may be familiar with. It can support low speed and full speed. And these 2 speeds are typically slow enough that the data lines for the USB port aren't super critical. You could get by with probably not doing impedance matching and just make sure that you route the 2 lines near each other and you'll be fine. But for this, I want to show you the proper way to do it. In the shortened version of this video, I'm not going to do the actual calculations for figuring out the exact specifications for the differential pair. But in the description below, you can find a link where you can access the full unedited version of this video that shows you all of the steps. So what we want is we want our lines to run right over this ESD. Okay, so we have our N on this side, our P on this side. Let's get those. And what we're going to do is we're going to go here, and I'm going to select the differential pair. And what it should do is it automatically knows these are N and P, so it knows this is a differential pair. And it's going to try to keep the spacing that we set. But I'm going to just make sure, because I don't think I've set this yet. I'm going to just do a custom. And we'll do, oh, this is actually, let me go under differential pair. Okay, so we want our width was 6.1344, and our gap is 6, and then the vias I'm not concerned about. So what you'll sometimes see happen is it does weird things when you get to the other connector. So sometimes you have to, when you're in differential mode, just draw it close, and then we'll go in and do single-ended connectors. I'm going to actually just scoot this over, and then we can just go in here with our single-ended and just connect those up. Okay, so there's going to the ESD, so it's not really that critical. This is not where the impedance matching is super critical. I'm going to just short these across, and now we're going to route differential again, and this is where it comes in more handy. And let's do it to there. Okay, and what I could even do is just scoot all this over a little bit, make it where it lines up. And now let's go into our single wire mode. Now, the only other thing we need to do is to finish this, and we'll do this in a moment, is this has to have a ground plane underneath of it. And ideally, nothing else next to it. Okay, now let's start placing some of these passive components. I'm going to go back here and take a look at the schematic. So we have C6 and 7, R6 and 7 go by the LDO. Okay, so let's take a look at those. We have 6 and or 7, and then here's 6. Then we have, I believe, can't see these. I think it's these two here. Okay, let me get rid of these values. Oops. Okay. And then R8 also, that goes with our LED here, D2. Okay, so let's go in here. I'm going to scoot these down. I'm going to get rid of these values. Okay, so we have, let's go back here. We have 6 on the input, and our input is right here, is pin 6. So what we're going to do is we're going to rotate this around, and something like that. And then this one here will rotate around input like that. And then of course, we can't have these on our USB data lines. Let's scoot this over, and I'm going to move this die designator here, and I'm going to leave that one there. Okay, then we have our these are the 2 feedback resistors, and these are very non-critical where you want them placed near the LDO, but they don't have to be in a certain position. Okay, let me get rid of this as well. And that, okay, and let's rotate these around. So there's our 3.3 there. Okay, so there's our inner point. Just increase this. Let's go ahead and do this up to 12, just to, even though the minimum 6 mils can handle the amount of current that we're doing, it's just, I like to beef up the power lines a bit. Okay. And now we just need to, we're going to tap this, tie that there. So this is just sensing the output, and then it's going to feed it back into the feedback pin of the LDO. And here's our enable, which is just tied to BN. Okay, so there is our regulator. We need to scoot this down so there's no overlap. Now I'm going to actually I'm going to change those, put those up here. And let me move this back up a little bit. Okay. So what do we have left? We have R8 over here, which is our current limiting resistor for our diode, for our LED. Once again, this is, I'm just going to increase it a little bit. It's not necessary, but okay, ground will be grabbed by our ground planes, and now we just need, we'll connect that up over here. We'll do that in a second. And then we have C1, 2, 3, 4, and R3. Let's see where these go. Okay, R3, C3, go with reset 1. R3, C3. I can put those over here by our reset button. And yeah, let's actually rotate these. And then that way I've got the enable on this side. I can just tie right up there. Maybe short those together. And then we need our 3.3. Let's actually take it off of there. This is no current whatsoever going down to this resistor, but okay. And then ground should pick that up by the ground plane. And then we just have, there's that. And then we have C4 goes with boot 1. And okay, and then we just have 1 and 2, which, oh, those are the decoupling for our ESP32. We really need those because we have to grab the pin here. I'll route that on a different layer. I'm going to move this a little bit lower. And let's bring all of, and let's just get rid of that. I'll reconnect it. Okay, so I'm gonna 3.3. Okay, that goes there. And we're gonna short these again. Okay, now we have room for our C1, C2. Let's get rid of the values here. Now I'm gonna connect these together with let's just do it 12. And then we're going to do a via, and let's make sure, yes, we have. So I've got 4 layers set up. We'll use the second layer for our ground plane. The third layer will be for a ground plane, but also some power routing. And then the top and bottom layers will be most of the other routing. Let's need to connect this via to 3.3. And then we'll do another via. Actually, let's go ahead and just start routing. I want to be on layer 3. Yeah, layer 3. And then place a via. Okay, there we go. Let's see what else we have. We've got ground pins that will have to be connected. We need to connect up our 2 switches to our, yeah, here we go. Let's see. GPIO 0 is here. So let's go. And I'm going to be okay. So now I'm on the bottom side. And let's go down here. And there's that one. Now we need, does this one go in the other corner? Okay. So let's go ahead and be down. And okay, so now we're going to just draw our copper fill or copper pour or fill zone. They go by lots of different names, but I'm going to go back up to my layer 1, and I'm going to do a place filled zone, and I'm going to just start here, and we want this to connect to ground. I don't want to remove islands. Minimum width, let's do 6. Clearance 6. Okay. Now just have to draw the other. I'm only drawing this approximately, which should be fine. Get close outline. Okay, there we go. And now I'm going to select that. Zones, I want to duplicate it. And let's duplicate it on the other layers as well. And it duplicated it, but it kind of shifted it. So I need to move it back up where it, whoops. where it aligns with the other ground plane. Okay. Now I'm going to go and let's just fill all copper zones. Let's check one thing here. Did not want thermal reliefs necessarily set on me. I'm just having to go through each of the 4 copper pores now, and I'm going to, okay, that one's on there, and then 4 solid. Okay. Now, okay, and let's go to the top level. I'm going to actually turn off these other layers. So you can see there's the copper pore. You can see it grabbed the via pins over here and here. The last thing we need to do is add ground vias to make sure the grounds are on the various layers, the ground copper pores are all connected together. And I'm going to just start by adding a via here. Let's connect it to ground and then we'll copy it. So maybe if we can get one up here. Here. These are all grounded, and it's where the power dissipation can happen. So we want to make sure we have a really good solid ground here for the heat transfer. Okay, then we have a ground up here. Grounds there. Here. Ground there. And then I'm going to do grounds next to every ground pin. Okay. And the last thing I'm going to do is just, it's not really that important, but I just want to move this via a little bit away from the data lines. Let me drive this line over here. Okay, let's make sure we're not going to go under here. This here should be good. Maybe move that a little bit further away. Okay. And one more thing, we have our U1 die designator way up here off the board. I'm going to actually move that down. Let's just put that maybe right here. Okay. Now we just need to fill our copper pores and run design rules check, and we can do that all as part of one step here. Refill zones before performing DRC, and then we also want to check to make sure our PCB matches the schematic. We have 0 violations, 0 unconnected items, and 0 error differences between the schematic and the PCB.